Okay, so today we're going to look at ambiguous case. We just looked at the GeoGebra animation where we saw a swinging arm for A. Okay, now if I give you a triangle such that you know an angle A, you know side length C, and you know side length A, okay? You don't know what it looks like. So let's just say you're drawing a picture and you're like, I have this, I have this, I have this. So what you see in your triangle right now is something that looks like this. And you're trying to look at this and you notice, okay, well, I don't know if I have a right angle triangle, but I do see that I have a side and a corresponding angle. Normally you'd be like, okay, I'm going to use sine law, right? This should scream sine law to you. However, before you start sine law, this is considered to be angle, side, side. Angle, side, side. The word that it shows is going to remind you that this is the ambiguous case, okay? This is angle, side, side. It's going to remind you, don't be because you want to make sure that you remember this is the ambiguous case.
Side, side angle.
You can write side, side angle. Let's write side, side angle if that makes us feel better, okay? So we're going to write side, side angle, and we're going to say, wait a second, is this the ambiguous case? And if it is the ambiguous case, we're going to check to see whether this side here is greater, equal to, or less than the height, okay? So what I would like for you to do is to calculate what the height would be if this were a right angle triangle. If this were a right angle triangle, we would use opposite over hypotenuse, okay? So we're going to calculate what is opposite over hypotenuse. What would this value be in order to make a perpendicular line given this angle here? If your answer for A is exactly the same as the value that's given to you, you'll know that you only have one solution because you'll have a perpendicular line. If the value that you get is, let's say, larger than the value that you're given, you know that the value that you're given will never touch this perpendicular line, so there's no solutions. If the value that you're given is larger than the height, you know that there has to be two solutions. Why is there going to be two solutions? Because this line here, as I showed in the animation, it can swing and it can be at any point as long as it's touching this line here that's creating the angle that's given to you. So right now, if you were to try and draw this A1, the length of this is going to extend past this dotted line. So we can't have that, right? It won't make a triangle. So if I say, okay, let me push that line all the way here, okay, now it's touching the dotted line. So this angle is correct, the side is correct. So this is one triangle that I can create. But what's ambiguous about this case is that technically I can also swing that arm so that I have this triangle here. When I have this triangle here, I still have the angle that's given to me. I still have the proper length for A, but I have a different triangle. So what we're trying to see here is that when this value that's given is greater than the height, we will have two solutions. Okay, so let's actually write that down. When the A value is less than the height, we have zero solutions. When the A value is equal to the height, that's one solution because it's perpendicular. When the height is when the A value is between the height and the C value, you have two solutions. And this is your ambiguous case. And I also wrote here when the A value is greater or equal to C, you're going to have one solution. And the reason why is because if this is your angle that's given to you, if your line is greater than the line out here, and the only way that you can swing that is to have your triangle come out here. This is no longer the angle that's inside the triangle. It's outside of the triangle now. Okay, so this triangle actually doesn't work. The only triangle that would work is that original triangle. Okay, it's easier to see in the animation. So if we take a look at the animation, you can see that when the line swings to the left-hand side, it's larger than the triangle. Okay, so take a look at that. Now, let's actually do the math here. This is all conceptual. What does this actually look like when we're trying to complete a question? So, let's say I say to you, there's a side length of AB that's 12 meters. There's a side length of AC that's 10 meters. Angle ABC is 52 degrees. Now, when you draw this, you might think to yourself, oh, that's not too tough. I can draw that triangle like this. This is 12, so AB, if this is A, B, C, angle ABC is 52, side AB is 12, side AC is 10. So when you draw this, you might think to yourself, oh, I have sine law. I'm just going to jump right in and do sine law. But in fact, before you do sine law, you need to calculate what this height is. Because if 10 is exactly this height, how many solutions will there be? One. If it's exactly the height, there's going to only be one solution. So we can't assume that there's actually a triangle that looks like this. It might actually look like a right angle triangle. Okay? If this length 10 is larger than the height, we might have an ambiguous case, and we might actually have two triangles. So the first thing I want you to do is let's calculate what this height is. Okay, using SOHCAHTOA, I'm going to do sine 52 equals opposite, which is my height, over 12. What's our height here? Can everyone calculate it? What's our height here? So 12 sine 52 is?
9.5.
What is it?
9.5.
9.5. So if this height is 9.5, is 10 bigger or smaller than the height?
Bigger.
Bigger. It's not equal, so it's not a right angle triangle. It's larger than the height. How many solutions will there be? Two.
I have
Okay?
a question. So
Hang on give me 1 second. So there's going to be two solutions here, which means that when I draw out this triangle, I could have one solution that looks like this. Technically, I have, so this is my original triangle. This is 10 meters. This is also 10 meters. I can draw a second triangle with all of this information still being true, but I will have two different answers for A. For this triangle, I'll have one solution. For this triangle, I'll have a second solution. So that's the reason why this is called an ambiguous case. It's ambiguous because there's more than one possible solution. Okay? Decide.
When you're like looking for the height and if it fits or not, do you take the rounded number or the non-rounded?
You can take the rounded number. That's fine. Okay, so when I look at this triangle, I'm going to solve it now using angle corresponding side. So now which of our rules are we going to use? We're going to ask ourselves a question. Is this a right angle triangle? No, so we can't use SOHCAHTOA. Do I have a side and a corresponding angle?
Yeah.
Yes, so we're going to use sine law. So 10 over sine 52 is equal to 12 over, sine C 1. Okay, so let's find out the angle C1. So everyone should be calculating what is the angle of C1. So remember that when you're trying to find out an angle, you have to use sine inverse, okay? So the angle C1 is actually equal to sine inverse of 12 sine 52 over 10.
71.0.
71? And we always round to the nearest degree, so we'll call it 71. Okay? What's the next step that we should take? Our goal here is to find out A1, the side, not the angle. What is the next step that we should take if we want to find out the length of this side? We can never use Pythagorean theorem in a non-right angle triangle. So if we want to calculate A1, what can we do here? Obeda?
3 sine 71 and 12.
Oh, you do.
Okay, so what can we do to get this? So remember, if you're going to use sine law, you need to have one piece of information
180
from this pair.
minus 71 minus 52.
Good. And what's that called?
Interior angle.
Good. Interior angle of a triangle. So we're going to take the interior angle of this triangle and we're going to subtract 52 degrees, subtract 71 degrees. Okay? And what is the value that we're going to get when we subtract all of that?
75.
I got a
57.
different, yeah, okay. I was going
Why
to say.
am I messing up my numbers?
I was going to say I got a different answer. So this is 57 degrees. Patsoon, do you have a question? Yes. Come grab a hall pass, okay? Are you feeling okay? There you go. Okay, so now we have 57 degrees. What's our next step? What are we going to do next?
Do use the sine law again.
Excellent. So we're going to use a sine law again. Always try and use the information that's given because everything else is rounded. So we're going to do A1 over sine 57. And we're going to calculate the value of A1. Bless you. So calculate the value of A1. Bless you. So in your calculator, remember if you're cross multiplying, you multiply the pair that you know divided by the one that's left. Okay? So everyone should have their calculator out calculating this. Isa, what did you get? Great. I also got 10.6. And let's add units onto that. And because all of these questions are multi-step, put each important value into a box. It'll make it easier to see. Okay? Now, this next part is where the ambiguous case part becomes a little bit tricky. So just take a look up here. Now, does everyone see the large triangle that I've superimposed? We've calculated that this is 71 degrees. Remember that these are both 10 degrees because, 10 meters because technically it's the same line that's trying to touch this dotted line. So we know these two angles are the same. If these two angles are the same, what type of triangle do we have? Isosceles. What do we know about isosceles triangles?
All sides are same. Equal.
No, not all the sides.
Two sides are equal.
Two sides are equal and two angles are equal. So if these two sides are equal, it also means that I know these two sides, these two angles are also equal. So they're both 71 degrees. Okay? Now, if I know that this is 71 degrees, it also informs what angle C2 is. So angle C2 is going to be a supplementary angle. So supplementary because a straight line is 180 degrees. So we can do 180 degrees minus 71. So angle C2 is equal to what?
109.
109. Okay? So this is 109 degrees. Now, take a look at that triangle. What do you need to do to calculate the side A2?
Find angle 18.
Find angle A2. How do you find angle A2? What is that called?
Anglization.
Angleization.
What is
Interior
that?
angle.
Interior angles of a triangle. What did you call? What did you say?
Angleization.
Angleization? That's a good word, Saram. Okay, so 180 minus 109 degrees minus 52. Tell me what that is in your calculator, please. 19. Thanks, Hanya. Okay, so now we have 19 degrees. Okay, folks. Do we have everything?
No.
We
Yeah.
almost do. What do we need to do to finish off this question?
Find A2.
Find A2. How are we going to do that? Give me your strategy.
Use 109 over 12.
Which law are we going to use?
Sine
Sine law? So which one? Which size do you want to use?
109.
So I hear that you want to use 109. This is a calculated angle from like quite a lot of other math. Always try and use the numbers that are given to you. It'll be more exact because they're not rounded. So let's do 10 over, yeah, sine 52 is equal to what? Which side are we comparing it to?
A2.
Good. A2 over,
19.
like this? 19? Sine 19, thank you. Okay, so calculate what A2 is going to be.
Then you can put sine 52 on the top and 10 on the bottom, right?
Yes, so an alternate way to write this is sine 52 over 10
And then
is equal to sine 19 over A2. So you could do that, but what you can't do is have it,
one only.
yeah, because the ratio is the same, right?
Yeah.
4.13.
4 point, can you round it to 1 decimal?
1.
1. Okay, therefore, the two solutions for A are 10.6 meters and 4.1 meters. Okay, can I just explain that one more time? Would that be helpful? Good, okay. So, what we were given at the very top is, here's an angle, here's a side, here is a corresponding side to your angle. As soon as you see side, side, angle, or angle, side, side, okay, you should say to yourself, oh, wait a second, this could be ambiguous. What you're gonna do is calculate the height. When we calculated the height, we found the height to be 9.5. Because the number that we have for side AC is larger than 9.5, we know that this is ambiguous. So let's just pretend for a moment, if this side was exactly 9.5, how many solutions would there be? 1. If this side was 8.5, how many solutions would there be? 0. Good. If this was 12, how many solutions would there be? Careful. 1, because an isosceles triangle would be
It's gonna
made.
be bigger than the
Okay,
triangle.
exactly. What if it was 16? How many solutions?
2.
1, because if it's larger than 12, there's only one solution that can be made because this arm can't swing outside, right? That wouldn't make sense. So any number that's between 9.5 and 12 will give you 2 solutions. So what if we had 7.5? How many solutions? 0. If we had 10.2, there would be 2 solutions. Good. Okay? So we determined the height is 9.5. There are 2 solutions. This drawing of our triangle is probably the most instinctual. It's what we imagined originally when we thought about our triangle. So when we solve this, we start with sine law with our given corresponding angles inside to try and determine one of the missing angles. From here, we calculated the third missing angle. From here, we use that third missing angle to determine our third missing side. Okay? Is everyone comfortable with this triangle? This should be pretty straightforward for us, yes? Good. Now, what makes this ambiguous is, hey, there's a second triangle here. So, what we're going to notice is with our original larger triangle, this side of 10 can also be drawn hitting the same line, creating a 50-degree angle but this triangle here is slightly closer to angle B, even though both of these are the same length. Because we know these are both the same length, it means that we have an isosceles triangle, so these two internal angles are going to be the same. So because we know this is 71, we know this is 71. We use that information to calculate the internal angle of this small triangle. We use that to calculate the internal angle of the third angle inside the triangle. And then from there, we use sine law one more time to calculate the length of A2. And then we state that there are two solutions. Okay, what length of B would cause a triangle to have only one solution? What length of B would cause only one solution?
That's the same
10.
as the height.
Well, 10 caused two solutions. 9.5.
Isn't that smaller than 10?
So the height. The height would create exactly one solution. What length of B would cause the triangle to have no solutions?
If it was greater
8.5.
than the
So
Greater than 12.
if it was
give
greater than
instead of giving me one number, in general,
Less than 9.
good. Less than 9.5, less than the height.
Triangle ER less than 9.5.
Triangle
Triangle
Oh.
Okay, so I'm actually going to skip ahead to page 15. Can everyone go to page 15, please? I want to practice doing this a little bit more with you, and I think it's going to help you out quite a bit, okay? So, for question A, 10A, I'm going to give you this triangle, ABC. For me, I like to draw the angle in the same place on the left-hand side. So when I draw this triangle, I kind of draw it like this. Angle A is here, which is 33 degrees. Okay? Always across from angle A is side A, which is 9. Okay? And then I also put the given side, C, up here. It just kind of, like, this is just an easy way for me for ambiguous case. So what I want to determine is, what is this height? So in order for me to calculate this height, I'm going to do sine 33 equals opposite, which is height, over hypotenuse, which is 7. So when I calculate the height, so put that into your calculator, 7 sine 33, tell me what you get.
3.8.
3.8. Okay, so if the height is 3.8, and here this value of 9 is greater than 3.8. So initially you might think, oh, this is going to have two solutions. But because this value of 9 is actually even larger than 7, how many solutions will there be?
1.
1. Good. Okay, so let's write this down. If C is equal to 3.8, there would be only one solution. If C was less than 3.8, there would be how many solutions? If it was less than 3.8?
0.
0. And if C is greater than 3.8, actually let's write between 3.8. If C is greater than 3.8 but less than 7, there would be two solutions. Because our C value is greater or equal to 7, it means that there's actually only one solution. Okay? So let's try it the next one. I think the more we practice this, the easier it's going to get for us. So I'm calling this angle B. It's 20 degrees. Across from angle B is side B. This is going to be my side A. Here is my height H. Okay, so I'm going to use sine 20 equals opposite over hypotenuse. Then we need to determine the height. Okay, so
Sine 20 equals
height over 5.
pi over 5.
Okay, so what is the value of h?
5 something.
What's the value of h?
1.7.
Good. So if b is equal to 1.7, how many solutions would there be? If b was equal to 1.7, how many solutions would there be?
0.
If the b value is equal to the height, how many solutions would there be?
1.
1. If b is less than 1.7, how many solutions would there be? Good. If b is greater than 1.7 but less than 5, how many solutions will there be?
2.
2 solutions. So how many solutions are there right now? We have 3. The b value is equal to 3.
2.
There's 2 solutions. Okay? So here for this one, this is 2 solutions. I don't think we wrote it up here. There's 1 solution.
Could we try the next one by ourselves?
Absolutely. Try the next one on your own. Sonia? C is not the hypotenuse. C is 7. Oh, sorry. I don't know why I wrote C. It should be A. Yeah, this should be A. A, B, C, A. Yeah. Okay guys, check your answers with my solutions on the board. Okay. How do we feel about this so far? It's okay? Okay, I feel like this requires quite a bit of practice. Let's just do another question together, okay? So if you want, you can take a photo of these solutions. Whatever you didn't finish in class today, you can finish up for practice tonight, okay? If you want, take a photo of this, or you can take it after class. Okay, can we go all the way down to question 21?
So I'm going to take a picture.
Yeah. So let's actually do one together. Draw a diagram first of what you think this triangle should look like. So here I'm drawing a triangle. I have angle B, which is 16 degrees, which means that B here is 17. This side is 24, so that means that's angle A. This is C, so what I want to calculate is side C. So first thing I want you to try and do is determine what the height is. So the first thing you're going to do is check if this is ambiguous. So we're going to write sine 16 equals to x over, or you can call it h for height, height over 24. So I heard someone say, Madge said height is 6.6. So if the height is 6.6, this side B is greater than the height. So how many solutions are there going to be? Two solutions. So this is ambiguous. Okay, so that was just to check whether it's ambiguous or not. Now I'm actually going to start doing the work. So this is part 1, this is part 2. Okay? So here I have my triangle. I'm actually going to draw it again just to help me kind of visualize it without that height in the middle. So here I have A1, here I have B, and here I have C1. What we know is 16 degrees, we know this is 24, and we know this is 17. You guys know how to solve this. I want you to determine A1, C1, and then C1, the side of C1. Okay, go ahead and do that right now, please. Go ahead and do that. It's A1 because we're going to eventually have A2 because there's 2 angles for A. Yeah. So there's only one angle for B, so I left it as B, but we're going to eventually have 2 angles for A and C, and also 2 side lengths for C. Okay, so here you can see that we used our known information, side and corresponding angle. So this tells us that we can use sine law, right? So here's our sine law. We use that to determine angle A. Once we determine angle A, we use that information, interior angles of a triangle, to calculate C1. Once we have C1, we utilize that information with sine law to calculate side C1. Okay, so who got that right? Good. Some of you guys are still working on it. When you're finished with this, try and draw your alternate picture of your smaller triangle. See whether you can start off this question on your own. Okay, and then I'll take it up in 2 minutes. Yep, sorry.
Do you have a quiz tomorrow?
Nope.
Show it on the calendar.
No, did I put that for you guys? It was supposed to be for my grade 10s.
Oh, no.
You were
It
supposed to
was-
have an
it was
assignment,
over.
but I moved it, yeah. Okay, guys.
Raise the washroom.
You're not. What's that?
Raise the washroom.
Yeah. Okay, so for this question here, we're taking our larger triangle, which was originally known to us. We take the calculated 23 degrees, and we draw our isosceles triangle. Okay? From here, because we know that both of these angles are 23 degrees, we can actually use supplementary angles here to calculate the inside angle, which is A2. So if this is A2, we use A2 and B to determine our third angle, C2. With C2, we can now use sine law to calculate this last value of C2. So our final solution is going to say that there are two solutions, 38.8 and 7.5 units. Okay? If you decide to do one of these questions for your presentation, I would say that this would be like a level 3 plus or 4 if you make it into a word problem. This isn't really a word problem here, right? Okay, so copy that if you need to. I'm actually going to stop the recording for today.